Welcome to Tomorrow's World Today, a show dedicated to the discovery of innovation and cutting-edge technology. We showcase the latest developments from the greatest companies and smartest people in the world. Tomorrow's ideas are out there. And through our journey of inspiration, we will create a plan for the park of the future. This is Inventionland World Headquarters. Here now is George Davison.
George, what are you doing? You taking a break, playing with your toys?
Hardly tomorrow. But I do have a question for you.
You usually do. What's on your mind?
Do you remember back in the old days, they had these big clunker, these cars. They were like the size of a dinosaur and usually had a lot of rust running down the side. I want to learn a lot more about the automotive industry. In particular, I'd like to learn about advanced GPS, protective coatings, and self-driving cars.
I don't know a lot about cars, but the one thing I do know is that the car I drive now is vastly different than the old station wagon my folks used to drag us around in.
Like from that movie, that family vacation movie?
Yeah?
I love that movie. But the cars now have such advanced GPS systems, you could never get away with a plot line like that today.
Why don't I find a few experts, set up some meetings so we can separate fact from fiction?
Sounds good. Hit the road.
I'm here in Tennessee at Eastman. Look at this incredible facility. I'm gonna take a closer look at the coatings on your car. What's the chemistry that makes the magic? Where does sustainability fit into the picture? I'm really excited to answer these questions and more today here at Eastman.
You must be Tamara. I'm Deep Bhattacharya.
Oh, thank you so much for meeting me. I really appreciate it.
Welcome to Eastman.
Now, you guys are almost a 100-year-old company, right? You started as part of Eastman Kodak.
We are very proud of our legacy. This site actually is about 98 years old, and it's been home to innovation across all the last 9 decades. Innovation is the heart of what we do, and it's the legacy of thousands of men and women who've worked in these laboratories to create products that stood the test of time.
Well, I definitely want to talk about cars today because that is something my boss is really inspired by.
Sure, and I've spent the last 8-9 years looking at the automotive coating, so I'll be glad to share my learnings with you.
Awesome.
So as a part of the tour today, we first came into our corporate innovation lab. That building is testament to hundreds of products that were actually designed and developed, and it's been used by customers, consumers for the last 80, 90 years. We then moved to the weathering chamber. So what the weathering chamber does, it allows us to look at any early signs of failure and then make corrections on the product design before the paint gets onto the car. So what you're seeing over here are some of the panels that have been coated. These are actually automotive paints. And what you try to do is expose these panels to some of the key elements of nature: sunlight, humidity, temperature variations, and then you got a combination of salt and snow in the winter season. So you have basically a source of light that is mimicking the wavelength of sunlight. And this chamber has additional capabilities to have moisture and temperature control. So the first panel is a freshly painted panel. This is something you see after 8 to 10 years of outdoor weathering. It is pretty close to what the initial conditions were. So 30 years ago, in a matter of 3 or 4 years, you had paint peeling out of the cars. And that was a bad situation because consumers were upset, they filed warranty claims. So it was a very reactive approach. Now the car makers have gotten smarter. They want a way to be more proactive in assuring the consumer when they buy a car, it'll stand the test of time. And what this instrument does, it allows you a very good predictive tool to look at the performance of these new chemistries when they get launched into new coating applications. Retroshield coatings are a game changer because it provides you with 3 key performance attributes: superlative performance, higher levels of productivity, and finally, and most importantly, it allows you to meet sustainability goals. So what we're going to be looking at over here is actually the wet paint. It's just been applied onto the sheet metal. In real world, it's a combination of multiple layers of coating. But if you think about it, the final thickness of the paint on this panel is less than a strand of human hair. So when you park your car in a parking lot, you have a shopping cart ding. You can also have scratches from tree branches. In the first case, you need a coating that's hard that can prevent a scratch. But it can't be too hard because otherwise it's going to shatter. In the other case, you actually need it to be tough so that it can absorb the shock from a shopping cart dent. The engineers and scientists at Eastman were able to develop a new product that actually provides you with this perfect balance of toughness and hardness. So you can now have a paint that is actually resistant to key scratches, to tree branch scratches, but at the same time, it'll resist impact from a shopping cart.
Man, I really could have used that growing up in Jersey. You got some tough stuff going on there in parking
Well, we'll see the market pretty shortly.
All right, then.
Now you've got the panel that's been freshly coated with a base coat, and that typically will be put into an oven, cured at about 140 degrees C for 30 minutes.
That's a lot of energy.
That is a lot of energy. And that's where car makers, what they're trying to do is lower the bake temperature from, say, 140 degrees C to about 80 degrees, or reduce the baking time. There'll be a huge innovation focus in terms of trying to get the cure optimized to reduce energy demands.
I know we're curing the panel in there, but I think that could be a good cure for our planet as well.
Absolutely. It'll really help you reduce the carbon footprint if you can reduce some of the energy needs in the paint shop.
Awesome.
So we saw the weathering chamber, we saw how paint gets applied. Now does it meet the performance?
All right, let's see if you hold up.
It's important for us to actually design materials that can last the life cycle of the vehicle. So when we put paint on new cars, we've got to make sure that it performs. So we'll go to the testing labs to see how the paints that we just sprayed stand the test of time, stand the test of performance. That is actually an impact tester, not rocket science, but it works. So here you take a certain load and you keep your coated panel on this substrate, and you drop a load from a certain height. That's what you start seeing are indents. That's why literally this is called the impact tester.
Keep it simple.
The challenges are many, and that's actually great for a company like Eastman because you get to work on real tough problems. But in the end, you're actually satisfying consumer needs and also keeping the environment a lot more greener. So looking at multiple substrates, looking at baking at lower temperatures, looking at move to higher solids so that you can lower the solvent emission.
So it's a story about things that are good for the environment, also being good for the consumer, also being good for the bottom line.
Exactly, and TetraShield, the resin systems that were launched 3 years ago, is at the heart of these three drivers. We now have materials that actually deliver better performance with improved productivity, so you can get more cars painted in a shorter amount of time. And at the same time, you're reducing the energy consumption and lowering the solvent emissions.
Well, thank you so much for teaching me all about the world of polymers and coatings.
Well, it was a pleasure, and thank you for stopping by.
Hello, Tamara?
Chris,
Yes.
nice to meet you. I have had such a fun day here
Excellent.
at Eastman, and Deep told me that you had a little scratch test I could try.
Absolutely. Eastman is committed to making a material difference by solving some of the world's most challenging problems. So if you want to be a part of a team that's trying to solve the world's toughest problems, Eastman's the place to be. So here is the scratch panel test that we set up for you. We have a two-component panel here where you have a premium automotive clear coat on the top part of the panel and a TetraShield developmental coating on the bottom. So all you do is you put the key here, you bring it down under constant pressure, and we'll observe the difference in scratch performance. So let's do the test.
All right, here we go. Carrie Underwood would be so proud of me right now. Whoa!
So which of those coatings would you like to have on your car?
I think there's a very clear answer to that.
TetraShield.
So what about you? Do you have a favorite color, a favorite coating or finish?
Absolutely, let me show you. Our definition of whether we really understand the application is, do we understand how our product is used in the customer's application better than they do? When we've achieved that level of competency in the application area, we know we have the opportunity to deliver novel, differentiated product solutions to the marketplace. Take a look.
Oh, okay, I see. I didn't have you pegged as a cherry red kind of guy.
Yeah, it's nice, isn't it?
That really has a nice look to it. So what do you think we're looking at in the future of coatings?
I know you've heard of autonomous driving.
Sure.
Well, there's a strong connect between coatings and autonomous driving. In an autonomous driving world, one car has to be able to see the other car. The technologies that are used to identify an oncoming car or a car in proximity is a reflective technology, and not all automotive coatings are seen by the autonomous driving systems today. If you think about the future of autonomous driving, without innovation in the coating space, you're going to be limited to the color palette, or you're going to be severely limited into the environment in which autonomous driving may apply.
Well, I mean, as long as we've got cherry red, I think we're okay.
Absolutely.
Thank you so much for guiding me through the present.
You bet. My pleasure, and you're welcome back to Eastman anytime.
Thank you so much.
You will.
Hey, Tamara.
Hey, George.
So what's the latest in shiny cars?
Well, I just got the lowdown on car coatings from the folks here in Kingsport at Eastman's Coating Division.
So what's the inside scoop?
Well, they do extensive testing here. They even do a test where they can replicate the power of sunshine so they can see how their coatings will hold up in states like Florida.
Wow. The power of sunshine in Florida, that's pretty strong. Sounds like they're on the right track.
Well, speaking of the right track and staying in the right lane, the other cool thing they told me about is some of the work they're doing with car coatings and how that may eventually assist with navigation in driverless cars.
I never knew how much tech there was in my paint job, but need to go figure out the latest technology in GPS innovations.
All right, I will go and coordinate that trip. See ya. After spending so much time thinking about car technology, my mind couldn't help but wander to GPS. While I'm here in Boulder, I'm going to be visiting with 3 different experts. My first stop, John Chapman of Cisco. He is a Cisco Fellow and a CTO service provider for one of the largest internet network companies in the world. I am taking a bit of a dive into GPS technology.
Oh, well, you've come to the right company. Cisco helped build the internet from the very beginning. GPS is a timing protocol, and we use GPS to help coordinate things. When we're actually coordinating devices like cell phones, we're looking at things in terms of a thousandth or a millionth of a second. Somehow, we've got to both use our phones in the same room without them interfering with each other. We need to be able to talk, and they don't talk to each other, they talk off to some tower. So behind the scenes, we've got all these communication protocols where the phones are talking to each other, and they actually make decisions that my guy will talk first, and then your guy will talk second, and they'll change the powers on the transmitters, and everything works, but it only works if they all have the same sense of time. It's like a drum beat, where everybody's connected in the same drum beat, and everything works together. And that's where GPS comes in, because everybody needs some reference to time, so it ultimately comes from GPS, and we actually carry time protocols through the network.
What happens if somebody messes with that timing that you're talking about?
It's really all about authenticating. We use the word authenticate to make sure that a source is the right one. We can actually take fingerprints of a GPS, like how it acts, what it looks like. We call it a signature, and if the signature is different, then you can qualify or disqualify. Make sure devices come from the right place or the wrong place. Luckily, that the security people are keeping up on top of this.
Well, thank you so much for giving me this overview. I feel much better equipped to continue on my GPS journey. Thank you so much.
All right, Tamara, thanks very much for coming by.
It's another snowy day here in Boulder, and I am at CableLabs to continue my GPS education.
Hello,
Hey.
you must be Tamara.
Curtis?
Hi, my friend John from Cisco said you'd be stopping by.
So what exactly is CableLabs?
CableLabs is a research and development company. We have 64 cable operator members that serve 180 million subscribers around the globe. So we'll start with the head end here. This is actually a replica. This is an interop lab for NFV and SDN. NFV is network functions virtualization. SDN is software-defined networking. So what I'm gonna be doing with Tamara is I'm gonna show her the head end, the nucleus of the cable system. And then from there, we're gonna go down to what we call our interoperability lab. And in that lab is a device. We call it a remote PHY device, with an acronym RPD. This is actually an integral component to an evolution of the cable network. We refer to this evolution as distributed access or fiber deep. This is called a remote PHY device, and what this actually is the physical layer that used to be in a head end, and now we're putting it out in a field.
What's so crucial about it?
It allows us to use more fiber optics in the network, which results in a cleaner signal. It gets closer to the consumer and allows for more capacity to the home. More megabits or gigabits per second, more videos to be downloaded, more applications to be run simultaneously. It's all about upstream transmissions. That's mostly where the timing comes into play, because this device ultimately is connected via coaxial cable to a cable modem. And this cable modem essentially has to be told when it can transmit upstream. So It's literally given a time that it can transmit so that another cable modem doesn't transmit at the same time.
Now that I have a sense of how crucial this infrastructure is, I want to know more about how we go about protecting it.
And for that, I'm going to send you over to my friend Greg at Microsemi. Here's the thing about high-speed data and capacity. 10 years ago, it was inconceivable that we would have a gigabit going to homes, but we always find a way to use it. We're going to build from there, build from 1 gig and go 10 times more to 10 gig. We have no doubt innovators will find a way to fill that pipe.
Now, for my final stop on my GPS tour, I'm here at Microsemi, a microchip company, where they're going to give me the big picture on how GPS is protected.
GPS, it's kind of the invisible utility. So the first thing we're going to show tomorrow is the Blue Sky GNSS firewall. This product protects against threats that can infect, if you will, the downstream receivers.
What are the most common kinds of threats?
They fall into two general categories, jamming and spoofing. Jamming is where someone might overpower the GPS signal and wipe it out completely. Spoofing is a little bit more trickier. Someone, for example, might be able to create a fake GPS signal. So what we've built into the firewall is what we call an anomaly detector to look and make sure that that GPS signal is secure. Our control room can look at Blue Sky GNSS firewalls that are deployed across the globe and see how well GPS reception is being received at each and every one of those locations. So what you're looking at is a very robust timing system, along with a backup system. In fact, some parts of the system even use atomic physics to maintain really accurate time, even in the complete absence of the GPS signal.
All right, physics, tell me more about that.
All right, this is a hydrogen maser that's using hydrogen atoms, and when they're in this state, they can maintain a very, very accurate time. If we were to lose GPS, we've got these amazingly accurate and stable clocks that feed into a system that is constantly measuring everything and making sure that ultimately time can be maintained even in the absence of GPS.
Do you build these here?
Not all here, but at our locations inside the United States.
Thank you so much for taking the time to help me understand timing systems better and to make me feel a little safer, a little more secure about what might happen in our future.
You're most welcome.
I'm here today in Chinook Farm, Guatemala, where I've convinced our friends at Chiquita to let me come hang out for a bit at their private airfield. Y'all know I love my gadgets, and I wanted to get a look at the high-tech side of banana farming. Crop dusting has been around forever, but what's exciting about what's going on here is the way that they're incorporating technology into the process. A combination of satellite imaging, software, and an expert team on the ground create a custom flying route for every plane that goes out so it can deliver exactly the right amount of fertilizer or fungicide where it's needed. More efficient delivery of product, better for the environment. Hugo!
Hi, Tamara.
Hey, it's great to see you again.
Yeah, good to see you.
Thank you so much for arranging this visit for me.
Sure. Let me introduce you the man, the brain behind this operation here.
¿Cómo está? Mucho gusto. Bienvenida.
So Arturo Lopez is the technical person responsible for the control of pests and disease here in the Chiquita, Guatemala operation.
I would love to see more about what you do. Could we take a look?
Pasemos adelante, por
Let's
favor.
go inside. The airplanes are having like a black box. That black box, everything is being recorded. Arturo can see here the path that the plane was going through this morning. And this will also give you a very important variables to do the evaluation of the performance of the flight this morning. It's giving you the farm, the volume, the amount of product that we were applying, as well as the speed and other critical variables important to measure the performance of each individual flight.
So data collection is really a key piece of this, collecting the data afterwards and analyzing it.
Definitely. It's very important that each flight, every time they do the analysis, so we can improve more and more flight after flight.
See, George, even in something that's been done since ancient times, like farming, there's a very important place for data. Well, thank you so much. I've got to get out of here and get on to my next stop, though.
We have a surprise for you. We have our pilot waiting for you to take you to the next place.
Am I gonna get to take a ride in the Chiquita plane?
Yeah, you're right.
Ah, now I'm really feeling like chopped banana. Thank you so much.
You're welcome. Let's do it. What we could explain to Tamara was how precise we are applying the exact amount of product that we need to apply in our farms That way, we are acting in a responsible way with our environment as well as with our communities.
Well, George, Chiquita's got me traveling in style. Look at what they hooked me up with. I'm gonna take advantage of this thing and head off somewhere exotic.
Tamara, good to see you're back from your journey. What's the verdict with automotive technology and GPS?
Well, technology keeps making coatings more and more effective, and GPS has functions way beyond just helping you figure out where to go in locational apps. That reminds me of my trip to Chiquita. I never got the chance to tell you about how they're using GPS to work with their fertilization process. I could see how applying GPS technology to traditional agriculture moves the whole industry forward.
That's amazing. GPS affects everything in our lives, even bananas.
Well, you know, I normally like to bring you a gift from the field, but the GPS antenna was too big and they wouldn't let me bring you back the atomic clock. So instead, I got you something a little smaller to remind you of the relationship between GPS and time.
A watch? Hey, is this your way of trying to tell me it's time to go home?
George, you have the best ideas.